Today, we're going to take it up a notch and explore advanced Matplotlib techniques that are going to elevate your data visualization game. Matplotlib, a powerful visualization library in Python that's become a staple for analysts and data scientists around the world. While many are familiar with its basic functionalities, I really want to dive in here to its more advanced features. This is what makes this library really powerful. It can take your visualization game to a whole new level. And in today's episode, we're going to jump deep into Matplotlib, focusing on creating multiple plots with subplots and providing examples for comprehensive understanding. Welcome back, guys, to another episode of PyPod Chronicles.
Welcome to PyPod Chronicles, a series that brings our tech blog to life in a whole new way. Covering an array of topics surrounding Python and tech, from programming tips, best practices, and so much more. Let's get immersed in Python with the Nerd Nook on the go.
Before I dive into today's episode, guys, remember you can get my handcrafted Python and Git starter pack absolutely free. It's a PDF guide that's built to help you in your Python journey, and it's resources that you can use absolutely free. It's the link in the description. Head on down there and get your copy, and while you're there, check out the blog. That's where all my advanced resources are. Alright, so diving into this episode, we need a brief overview of Matplotlib. If you missed last week's episode, now would be the time to jump on back. Matplotlib simplifies the creation of static, animated, and interactive visualizations in Python. So I could do something like a simple line plot or more complex heat maps. And this gives us a wide range of customization options. It's a trusted library that gets used by scientific publications, so a lot of people are using it. Now, there are other libraries out there. Okay, so there's one called Seaborn, but Seaborn is really just an extension of Matplotlib because I can bring it in and use it here for heat maps and stuff. But Plotly, right? Plotly is just used less in actual publications or used more by data analysts. It's more of an interactive dashboard. So when you want interactive plots, Plotly is the way to go. But let's just focus on the godfather here, which is Matplotlib. As datasets grow in complexity, the need for sophisticated visualizations arise. Advanced Matplotlib use allows for the creation of intricate plots that effectively convey more complex information. That's what we discussed in last week's episode. You saw how we can create a good-looking chart to represent your data. This week, I want to dive deeper into that with the use of subplots. If we just do a basic review of last episode, right? I introduced line plots, scatter plots, and bar plots. And these really set the stage for more intricate visualizations. With today's episode, we want to talk about creating multiple plots. So the best way I can visualize this without a picture is imagine a window. And a window is split into 4 components, or better yet, on a piece of paper. If I ask you to draw a window, right? How would you draw it? It's probably like a rectangle that has 2 lines and there's 4 components, right? The top left, top right, bottom left, bottom right. Okay, so the window itself is the subplot. And then each of those components is a plot within the frame. So we can have a 2x2 grid, just like you drew on that window. Okay, this is really what a subplot is. It can have more than that too. Okay, I could have 1 column and 3 rows. I could have 4 columns and 1 row. It's up to you how you define your subplot. But this allows you to showcase different aspects of your data simultaneously. To create a subplot, I'm going to create a figure as well as an axis. So typically in my code and in other examples that you've seen of Matplotlib, you'll see something like figure and then axes or AX or AXS. Whatever. I create 2 variables and the value of this is subplots. Now, subplots is a function that takes a few arguments here. The first 2 is the number of rows and the number of columns. So for example, if I want a 2x2 grid, I'm going to say 2, 2. And then you could give a figure size as well. A figure size is a tuple, and what it does is it basically allows the subplots to be adjusted so it's not distorted in any way. For my example, I said 12 by 10. And then when we go to plot, because a subplot has 4 components now, I'm going to use AX, or your axis variable, with an index. The index, so the window frame in the top left of the window, that's 0, 0. So 0, 0. The window frame in the bottom right is 1, 1. Okay, so we have to adjust where this plot's going to go. And then you could choose any plot, like a scatter plot or a histogram, a bar plot. It's good to know what each of these plots are really good at. That's when we know when to use them best. Scatter plots are effective for visually revealing patterns or relationships or outliers in two-dimensional datasets, facilitating the interpretation of data distribution in those correlations. A histogram is completely different because these are useful for displaying the distribution of a single variable. They showcase the frequency or density of different values and identify patterns or skewness in the data. Another popular chart you could use is a bar chart. Now, a bar chart is very similar to a histogram, but bar charts are effective for visually comparing magnitudes of different categories or groups. They provide a clearer representation of relative quantities. I've touched on scatter, histogram, bar chart, and then our last one, right, is just a normal plot, a line chart. And these are just illustrating trends or patterns over a continuous period of time. So think of like the stock market, crypto, right? That's a line chart. Easy to look at, easy to grasp. Once you've set up your subplot, right, it's still about the visualization. You're telling a story. Be creative here. Your inner artistic abilities can come out if you have any. So you need to craft aesthetically pleasing plots. So using color maps or styles. Choosing the right color scheme can significantly impact the readability and the aesthetic appeal of your plots. This is why Matplotlib offers a plethora of color maps, or the parameter C map, allowing you to experiment until you find the perfect fit. As a bonus, you can experiment with different styles to give your plots a distinct look and feel. This is the old school way, is I could use the Matplotlib library, so plt.style.use. Inside use, you would put a string of like a seaborn style. And you can still do this. It's just there's new ways to do it. So let's talk about a few best practices for Matplotlib. Now, efficient use of resources. This is key. Creating a multitude of plots can sometimes lead to inefficiencies if you're not managing your data and visualizations correctly. Let's explore strategies to optimize that code and your resources when dealing with a large number of plots. The first up is batch plotting or rendering. And this works best with large datasets. Creating and rendering a massive number of plots individually can be resource intensive. We want to avoid that. So this is why we do batch plotting. I can plot the whole batch at one time. And it's where you create several plots at once and then display them together. This minimizes the overhead associated with rendering each plot individually. This is why we use subplots. Okay? If I wanted 10 different plots, I would have to run them and a plot would have to appear 10 times, right? So think of like a generator. I'm yielding something every time it loads. So it's like plot, close, plot, close, plot, close. That's repetitive. It takes up too much time. A subplot is us creating a batch of plots that I can render or display on the screen all at the same time. We could also do lazy loading. So for interactive applications, lazy loading is great. Only load and render the plots that are currently in view or in demand. That's what lazy loading is. This can significantly reduce the initial load time and resource consumption. Now, to optimize your code for better performance, vectorization speed is key. Matplotlib supports vectorized operations, which can significantly speed up plotting, especially with any numerical data you might have. By avoiding any of these explicit loops and importing NumPy to use vectorized operations, we can use the underlying C implementation, resulting in faster, more efficient code. The ability to reuse axes objects or AX objects for each plot can be costly. Reusing the same object for multiple plots improves efficiency. This is why subplots is so great. And remember, for memory management, all right, use the clear method. Clear plots you're not using. It's going to make Python run faster. This was a fun episode, guys. To tie up and wrap up this episode, we dove into advanced Matplotlib techniques, and this is an indispensable episode for any data enthusiast. From storytelling your insights through multiple plots within one subplot to mastering any design nuances that come with Matplotlib. The toolkit that we've explored so far is vast. Efficient resource usage and optimized codes serve as essential pillars both in captivating and responsive visualizations. As we wrap up this chapter, remember, this isn't a conclusion but a catalyst for further exploration. Embrace the dynamic nature of data visualization, experiment with colors, layouts, and those interactive features, and let your creativity shape compelling narratives through your data. Guys, before I let you go, here are 3 key takeaways from this episode. Any final questions you had? Matplotlib is not suitable for basic plots. Well, stop. It is, but you can also use it for advanced plots. Okay, it's great with complex visualizations. Any troubleshooting errors, right? Read your syntax errors. Make sure that your library is up to date and review the documentation, right? Because that's constantly changing. The advantages of using subplots in Matplotlib is they allow you to display multiple plots within a single figure, facilitating the comparison of different data sets along the way. Well, guys, remember, if you want to get my Python guide to get started, it's absolutely free. It's the link in the description. Head on down there and get your copy of my free handcrafted Python and Get Starter pack. That's all for today's episode of PyPod Chronicles. I hope you guys enjoyed. Drop a like, comment, restack, whatever platform you're viewing this and listening to this on, as that helps me grow. Until next time.